Hey everybody, this is Luke Parisi with a video on the 3D engine I've been working on. I didn't post last week because I was working a lot on trying to figure out hardware instancing. I, I got the instancing itself working from what I understand, but with even working on basic shaders, as I was trying to learn a lot more about shaders and that, I couldn't get textures drawn in the shaders, custom shaders for some reason. I posted to MonoGame community as well, and there was a few suggestions and no luck though. So I kind of have put that to the side for now, and especially with some of the new changes I've done to this. So one of the changes, I've split the model and its texture. So possibly with that change, the custom shaders could work. I just have to see how I can pass in the texture itself to the shader as well, separate to the model. But I'll show you some of the other stuff first in the 3D game, and then I'll go into the other project where I was practicing instancing. But there's been a few changes. I've got a print screen of the patch notes that I will go through, and I'll go through them in order. So the first thing, after working on all the hardware instancing and that, I just made my own custom model. It's pretty basic, it's just this, and I put a texture on. So what I'm doing with the models is I have to make them in Blender, or there's a few I've bought, but I have to import them to Blender and export them and draw my own textures for them as well. But yeah, what I have to do is get it in Blender, and I have to learn a bit of Blender as well because I haven't really used it before, and then generate a UV map for that object, and then I can create the texture for it. And now currently it's split the texture in the model. So this is pretty basic. It's just a wood pole. So these are some of the other models. So I bought one pack to start practicing with. I forget the name of the people who made them, but it's called the prototype pack, and the models are really good. It was only one pack I've bought so far, but they've made a bunch, and I've been playing around with the models in this prototype pack, and yeah, had a lot of fun, especially like this crate. I'm so happy with it, and the texture I did myself. So yeah, what I had to do, they had their models in FBX, well, .fbx type, and I even tested it in Unity, and Unity, it handled it so well. You just import, click and drag. But in MonoGame, firstly, didn't like the FBX, and then so that's why I had to bring that into Blender, so import the FBX into Blender, and then export as a DAE, but as well do the UV maps, and then I have to make my own texture. So it's a bit of a process, but yeah, at least the models are great. Like this one is so much better than anything I could probably create in Blender. And some of the other ones are really good. There's a tree, it's over there as well. I think you might have seen it when I started the game. But yeah, gets it. What am I colliding with? This floating plane. But yeah, there's the top. And I've done a few basic doors. This one's part of the pack as well. The textures are mine. Basic textures in this one as well. And there's a bit to show you about the doors as well later on. So going by the patch notes, the next thing, so I added a level system which handles now level transitioning and yeah, the level switching. But as well, there's this. So when I first started with the level system, I had it just on collide. So when you collided with the object, it transitioned you. And then I made this So it's like a aim ray. So if that aim ray intersects the model itself, then you see that press E to interact. And if you get too far, it doesn't say it. So this ray at it pretty much shoots a ray from your position to your target. So it's pretty much like where the cursor is pointing, shooting a ray. So as you see there, right as it intersects, it does that and intersects there with the axis aligned object there. With oriented bounding box objects, I actually have it as a sphere because I was getting a bit of issues at the moment with ray to OBB collision. So for now it's just ray to AABB, but ray to bounding sphere, and then I just created a separate interact sphere for the objects that are not axis aligned. So then this is the level transition. I've just made another basic level. So this could work as from level to level, let's say like one outdoor environment to the other, or like the doors are, let's say this is the outdoor environment, this is a door to the interior of a house, then it would work the same way. And as well, there's a little system that I get all the interactable objects. Well, I'm just getting the vectors or creating it separately, and a list of vectors that are the world positions for all the interactable objects. So see here, when I interact, it transports me directly in front of this object, same on the way back. So that's just those, it places you at that vector of the specific object that you're transitioning to. So that's the level system and level switch. I've changed the collision quite a bit. The first collision, first when I changed the ramp collision, I had it only do what it was doing, which was that upward momentum on, if there was a keyboard button movement, and then there was only the jitter if you were moving. So if you stayed still, it wouldn't jitter. But I've changed that again, and I'll go through the collision overhaul in a bit as well. So yeah, play array interaction as well. There's a binding for it to interact. If you update it, it'll say press F. So that updates on the fly there. So press V and there. So that's bindable and updates that text and functionality on the fly. So yeah, as I was saying, I split the model and texture functionality. I can't really show that, I have to show that in code, so I'll show that after all the demo. And I cleaned up a lot of the model code as well, and yeah, added a bunch of new models. So this is another one, the tree, which is all part of the prototype pack. But yeah, this one I might change up the texture. I mapped myself again, and I might adjust that size. It's just a little tree at the moment. But yeah, collision, everything. It's just a axis aligned box there. So yeah, I'm not doing any per plane per collision, I guess it's called, but I was going to say per pixel collision, but yeah, nothing like that. I've only got axis aligned and oriented bounding box collision at the moment. So I mean, like this, I can have that ABB a bit thin, like a long rectangle, but yeah, then that bush up the top there you would go through it. So I've got it as just a big square for now. Alright, so next up is I've added a save and load system. So it's only passing in a few variables at the moment. So let's say we're standing here. If I exit and come back into it, I'm in that same position. So it doesn't save your direction that you're looking, but yeah, your position, and then the system that's set up, when there's more things to save, it'll go into that same save file. And yeah, pretty straightforward. So you can, like at the moment it just says main menu and quit, but it does the save method as well. So I'm probably going to just add highlight text, save, and quit to main menu, just like that. See how that says close? So I'll just add highlight text on these two, save and quit main menu, mainly because I won't be able to fit the entire text into these little, and I don't want into these little buttons, and I don't want to really change the buttons. I can small the text, but it'll probably be too small. So that's the save and load. So if you start, this just starts anew, and then you can, so if I load that, it'll load back. And it's the same with the level you're in, so it saves your position and your level at the moment. They're the only two variables that it saves. So let's say I'm in the level 2, which I'm going to rename. I've just got it leveled as level 1, which I've just got it named as level 1, level 2 at the moment. So yeah, I'm in level 2 in this position, and it's there. So yeah, it saves your level, saves your position. Next up, change most, went through that, add door models. So yeah, these door models were the first doors I put in. So these ones have no movement or anything. It's just the door, you interact with it, and it plays that sound as well. This one, it plays that sound, but the level transition occurs before it plays that sound. So these ones, because there's no transition there, it just plays that sound. And yeah, no movement, so they're like locked doors. And this one here, this is door 2. I pretty much just haven't done the texture yet. I've just generated a UV map and applied that as the texture. But this one, yeah, opens and closes, and that took me a bit longer than I thought it was going to take, because there was a few things, mainly with the collision and the interact sphere and making sure it doesn't slide off, which is what it was doing. So every time I opened, so I would open, it would slide a little bit, I would close, it would slide a little bit, and then if you just kept opening and closing, the door would move over there. So just fixing things like that, and having this limit on the rotation. So I'm pretty happy with that door. But yeah, that's just one of the simple effects. It's just, yeah, that rotation effect on the door and that sound applied. But yeah, and the collision box updates nicely. So, and yeah, that was the other thing. So the doors these don't have a centered rotation. It's rotating around this point here. So that was part of a little bit of a problem, because everything I have in this rotates around the center. But it's pretty much the same formula I used back in Lords of Delusia for the ships in that. So every every gun had a position that wasn't centered. So the bullets would have to be created at those points. So it was a non-centered rotation point. And it was pretty much the exact same thing that I had to do for this, just adjust the rotation point for this, and then yeah, apply the changes to the oriented bounding box and everything. So that's all that, and I'll go through that in code anyway. And yeah, so now I'll go through all the collision. If there's pauses in my talk, it's because I'm looking at the screenshot of the patch notes. So what I've written for this ramp collision now uses model forward vector to calculate the incline for player. So it's still a bit jittery, but it's less. But what it's always doing is getting the orientation of the model, getting that forward, so the orientation dot forward dot y, only the y I'm getting, and then applying it to so when the player moves forward, or I'm not moving up if I press A for some reason, but it works on, I've got to fix that. So if I'm going backwards uphill, if I'm strafing right, it's going, but not. Wait, what? Something, I've got to check that. That's probably something to do with frame rate. Yeah, it's definitely something to do with the frame rate. I thought I removed all frame rate dependency there, but clearly I didn't. But yeah, so that adjusts your Y position. So say you're on a flat surface, all this does is move your X and Z, move along your X and Z. No adjustments to your Y is applied. But if I'm moving forward and I'm on something like this with a slope, so the forward vector of this would have a different Y alignment, so that adjusts so that moves you up slightly on your Y as well when you're pressing forward. So here you're pressing forward, it's just your XZ is changing. Here your XZ with the Y increase as well is being applied on the collision there. So that's just done for the ramp collision. There's different collision now for the active rotation. So here it's similar to just applying the movement upward, but it's based on your position to the center as well. I think I still have it like that. I changed it. I made so many changes I can't remember what was what. And as well, I'll just reset the level so we get this one here, and that's why I have this one, because what it was doing was only moving you half the time, because with transitions, but that's because pretty much, say you're colliding with the floor, so one frame you would be colliding with the floor, and it'd say, all right, I've got a collision, I revert to the last position, there wasn't a collision, because that's pretty much how I'm handling the collision with the walls, with the floors, everything. And so that was what was occurring with even these objects that are moving. You would collide with it, would say, all right, there's a collision, apply the translation that this one has, but also it applies the revert to last position in the y-axis, let's say. And then for that next frame, there's no collision. So no translation was occurring on your player. So only half of the time your player position was moving. So I've just fixed that to now have, if you've collided recently with the transitioning object. So frame 1, you've collided with it, it runs the isRecent collision method, and then if that method ran on the last frame, it runs it on the next frame, and then sets that variable. It just sets it to 2 if there's a collision, the recent collision float, and then every time that method runs, it just subtracts 1 from that, and then on collision again sets it back to 2. So that's the transitioning fixed. It was noticeable only on the XZ axis. The Y, that one here when you're standing on it, because it's moving upward, it always worked anyway. So that's that. Walls are fixed up completely, and the doors work similar to the walls. I think exactly the same. But now when you collide with a wall, it maintains your... So here I'm moving directly on the Z, here I'm moving directly on the X, but let's say I'm moving 45 degrees, now I'm colliding, there's a Z axis collision there. I want to keep moving the player on the X axis, so all I'm doing is stopping the movement there on the Z axis and allowing the X axis. So it was like I talked about in the last video, but as you saw, I had problems in the corners. Now I believe, I can't remember if I've kept it or what, because I made again a lot of changes. I have just a future bounding, so the player bounding box, I just have the future position. So I'm doing that collision detection on the future bounding box collision compared to the wall. So the mins and maxes, and I'll go through the code after as well. So that's now the wall and door collision fixed. So I'm pretty happy with that. And active rotation collision change to be a bit better. So yeah, that was that active rotation. It's still a bit not where I want it. Like this, I haven't done the movement translation, but I've kind of figured how I would go about it, and that is getting the player position relative to the center of the object, and then applying say on this one it'll be the XZ position change based on that, or the radius, I guess. So it's like a circle, you know, it would move you around that circle based on the radius from the center. And these have, yeah, it just pushes you up at the moment. It's the same functionality, pretty much, just a bit cleaner in code, and it works better. But yeah, for some reason the Z-axis, or I think this is X-axis rotation, it doesn't push you as fast as so if that was the Z, this is the X. This one pushes you up a lot faster than the other one. For some reason, I don't know, they're rotating at the same rate. So yeah, that's everything I have in the notes. I can't remember if I did anything else. But yeah, that's everything for the game. As well, I'll show you what I've done with the hardware instancing. I'll just keep this as desktop. So there was a example instancing project on GitHub. I forget who it was by, but there was a good example, good example. But they were using their own primitives, and yeah, it had texture. I guess I should go back to that example, because I think they had textures and the primitive separated as well. But yeah, so I pretty much reverse engineered it to use models instead. So this at the moment is using the wood pole model, and as you can see, there's no texture, and it seems to be rotated wrong. So that's where I got to at the moment with the instancing. But yeah, as you can see, the instancing itself is working. So it's only drawing the one model. Well, there's only the one model, and then it's instancing everything else. It's a bit choppy because I'm running in desktop mode, but the frame rate, it's hard to see up here. It's 300, 400, and that's like a heap of, I think, 2,500, 5,000 objects there. maybe even 10,000, I think, compared to in the game, which I don't have instancing at the moment. The frame rate would be a lot lower. So yeah, instancing is up there. I just have to fix the final texture problem, but I'm having that problem without instancing as well. So even in the basic shader, I was having problems getting that texture in as well. So it wasn't. So I thought it was a problem with how I was doing the instancing, but it was just a problem with the shader itself. So yeah, I'll go through all the stuff now in the code as well. So I just wanted to demo it all, and now I'll go into detail a bit more about it. So I guess I'll start with the level system. So now, yeah, this is all part of splitting. There's level objects as well, which is all part of splitting the models in each level, as well as the models themselves. So level objects now get applied to the grid, and this was part of splitting the models and textures as well. So yeah, textures is just a list of, if I go into this, it's just a list of texture 2D that I can apply to any object I want. So like, say create texture. Yeah, so I'm using that here in the model render. So I've just added the texture 2D that to its constructors. So there's two constructors as well now, one without the texture and one with the texture. So with this, if I ever need to have a model that doesn't have any texture, I'll just call that constructor. But yeah, anyway, I was going through the levels first. So yeah, that was all part of splitting all the code up, splitting the models up and that. Now level, yeah. So instead of having everything on the gameplay screen as well, I just call a new level object, which I pass in the current level ID, and current level ID is a global. So the save and load obviously writes to that global. So it starts off at level, where am I setting it? But it starts off at level 1, let's say. Yeah, load fresh. And then, so if you click new, it just runs load fresh, which sets your current level and start position at the moment. And I've got this save manager as well. I've done so much changes to the code that it's going to be messy even going through it. But the code is a lot cleaner, not as messy as how I explain things, but yeah, the code is cleaner, a lot cleaner. So yeah, save manager, which handles the saving. So yeah, as you can see here, save game info data. I'm just getting the position and current level, and then so this saves to a save file, and then I encrypt. I've blocked my encryption at the moment. But yeah, I've got an encryption. It's pretty much the encryption and decryption stuff I was using in Battlecourt and even Lords of Delusia. But yeah, this just encrypts with MD5, and I definitely won't show you the salt and that at the top of this class file. But yeah, so this is the save and load. So that level, your current level, gets handled in the save and load as well. But yeah, so you start at level 1 if it's a fresh start. But there'll be more descriptive level IDs. So yeah, I'll have because this is going to be an open world, well, if I get instancing working, it'll be as open world as possible. If I don't, it'll be more like I guess how Deus Ex handled it with large environments, but if you get to a certain point in the environment, it transitions to the next level, let's say, or how I think how the Elder Scrolls 2 handled it as well, because that's kind of what I've got in mind when I'm making this. What this game will be is something like the Elder Scrolls 2 Arena, something open world, but a lot to do. And I talk about that game fondly, but I've never played it. I've just watched a few videos on it, and yeah. So I guess in my mind, I've got what I think that game is like. So I'm not. This game is not even based on that game. Really, it's based off my idea of what that game is. So yeah. Anyway, back to level. Now let's go back. So yeah, each level has a list of level objects. So this I've got to clean up as well, but there's a bunch of lists that may or may not be in each level objects list. So if I go back to gameplay screen in level. So gameplay screen creates a new level with a level ID, loads that level, which has so now camera, gravity, collision, grid, even the player interaction is in that, and level objects, which is the list of all the objects on that level. And then so I've got everything that happens. So camera gets updated here, level objects list, player gets updated, collision, it's all in here now, and there my interaction methods in that, the interaction class and all this methods are in here as well. So yeah, that's cleaned up a bit. Now levels with the level ID, and yeah, it's a lot cleaner. I don't have to have everything in gameplay screen, because even in Battlecore, can't believe I just left everything in the gameplay screen. I didn't even bother to clean it up a bit. But yeah. So in this, I'll still have all my gamepad and my mouse type stuff here. My menu, all my menu handling still in here. I kept that in so I can remember the sort. Yeah, that's the levels. I'm reading the thing at the moment, so I guess I'll go through the collision next. I don't think there's much to really go through with the levels. It's pretty self-explanatory. I have level objects. It calls all the new classes I've made, like interaction. So this level is just pretty much a wrapper for the level. So I don't know if I should explain anything else about levels. If I think of anything further on, I'll just go through it. So I'll go through collision, the changes to collision now as well. So it's the same collision class. Here's my new update translation. So as you see here, model recently collided with frames for that model. And then, so as you see, when update translation runs, it subtracts one of the recent collided with frames for that model. But if there's a collision, which calls this update position, it sets it to 2. So if I find all references, so here I'm calling it in the player model collision. So I'm running the usual AABB and AABB to OBB and AABB to AABB methods here, I've kept these brackets in just in case I ever have to add some more methods. But yeah, so I've still got those in, which updates your position and that. And then after the collision, the collision is done, it checks if the model recent collided with frames is greater than 0, and the translation amount is not 0, so this won't run for models that don't have a translation. So, and then we run that method. So that's why it's separate as well, because even if a collision isn't occurring, even if neither of these collisions are happening, we still want to run the translation update, because as I said with that, the collision happening every second frame, yeah. So that's pretty much just the extension I've done to handle the translation, the player translation. Now, so here's the collision I've done with Ray to OBB. So as you can see, I've just got it intersecting with Interact Sphere at the moment, which I will probably go back to that book, the Game Development Cookbook, because I was going through that and had a bit of issues going through some of the stuff they were describing, probably because they went through it at the start of the book. But yeah, so I have to fix that too, because this is just calling the inbuilt intersects method in MonoGame, and that only takes in an AABB or a sphere or another array or a plane, and I want that to have collision with an OBB, so I would have to build my own custom Ray to OBB collision methods, just like I did with all this. And I tried it with this, and how I looked at Ray, how I was thinking with Ray was only so it was like this. So a Ray is like an OBB, except you just need to get one angle. So I tried that with, so it was similar to this, except it was getting interval of 1 and just casting a ray to the other, and then I was doing a overlap on axis, because a ray is its axis. So I was just doing overlap on axis check on that, but it wasn't right. So I was doing something wrong. So I left it for now and have it as, if it is a OBB, then I have it as a intersect sphere, which is, if I go to model, so here I have frustum view sphere and interact sphere. So they're a bit different. The interact sphere is just half of the size of the frustum view sphere. That's it. But yeah, so that's how I'm handling that ray collision, which is used in the detective. If I want to draw, let's say, that text, press E to interact, or allow that if you press E. So if that condition is met. So I'll show you where I'm using it, and you'll check interactable wrappers upon wrappers. So yeah, another wrapper. But yeah, in this interaction class, which I'll go through a bit later, so if that check interactable, which is if the ray colliding with the AABB or the OBB, and And so if there is that, if that's true, then we check if the key is pressed, and then play this, and then this runs as well. I think yeah, there's a part where I'm handling the distance as well. Hang on, maybe it's in check interactable. Yeah, model get distance is less than the interact, so I've just got that as a distance static there, but I'll go through interactions. I'll just go through it after collision. So that's how I'm doing collision for the rays. Now, how I've cleaned up the walls, if I find it, and I've got this handle vertical collision method now, which it does on the walls and the doors. I think I had it in active rotation as well, but yeah, I've removed it. So yeah, this is as well, that's the active rotation. As you see there, so I've removed the distance from the center thing, but I've just got the Y update based on the rotation plus the Z, and then if it rotates on the X and Z axes, then it updates your Y. I had this as well, pretty much duplicated cam position X, and this would be, let's say it's cam position X updates, then this would be on the Y and Z. If this was Z, it would be X and Y. So yeah, that's how I'm doing that at the moment. Yeah, I had that, and it was pushing, so say it was rotating, as you saw before, it was pushing you to the side as well, but that was because the rotation is, it's just one value, it's pushing you in one direction only. So if you're at the top and it's rotating to the left, then it would push you to the left. But if you're at the bottom and then it collides with you at the bottom, it would push you at the left. It would push you towards the left as well through it. So yeah, that wasn't correct. Even this, it's not completely correct, but for now that works, because I still don't even know how if I'm gonna use many active rotating objects. But yeah, and yeah, I've got this Boeing. I'll show you. It's pretty funny, and I've kept it because if I want to have like bouncing objects you can bounce on, then I'll just have that. It's choppy, yeah, because of desktop mode. But yeah, this. Okay. It was bouncing. Hang on. This bounced. Player Y velocity. Yeah. I guess I can't show it off. I can't remember what I did, but this caused me to bounce. It's a shame. Anyway, so yeah, that's the active rotation. Here's the ramp. So yeah, as I was explaining, just get the forward and multiplying by 0.01. That gets cast to the Y-pos adjust, which is just a float, which gets used when you're key down. So because, yeah, I'm not sure why it was frame rate dependent. Yeah, actually, so each frame I'll have to go through that off camera. Why? I don't know why it's frame rate dependent. So yeah, that's now the ramp, which is using this. I've got a handles vertical collision because what was happening with the ramps underneath. So if you remember before, when you're underneath and you collided with it, it just pushed you up. but now that handle vertical collision prevents you from going through the object underneath, which was part of the fixes. Yeah, I don't know why that. Yeah, it's definitely frame rate dependent. Anyway, so that's that. Now handle vertical collision. So yeah, I'm getting the future bounding box of the player. So that's just a bounding box of your. Hey, this isn't future, this is current. I did have a future, but I'm getting current. Which, yeah. I did have it as future. And then I changed it. I must have changed it. I see I did so much code changes that I can't remember what I do. But there was I'm pretty sure there was a reason I was doing it here and not just using the player bounds. I think because this is running before. Yeah, it does this. It must be doing this before applying the pushback. Anyway, let's just talk about. So I'm just getting the bounding box of the player, and then yeah, if model is, I'm doing it again here, checking if it's rotatable or not, because I didn't want to just create two separate methods again. So as you see here, because this method here gets called whether it's OBB or AABB, see? And yeah, so because that's getting called in both, I'm just doing this check again if it's rotatable or not. So if it's rotatable, I get the OBB vertices, and then I get the bounding box. So let's say we're colliding along the x-axis. So I'm getting the rightmost part of the player box, and if it's less than the minimum of the object it's colliding with, or the minimum, so the leftmost of the player is greater than the rightmost of the model, then I still allow the Z. Sorry, my cat he wants a lot of attention. So yeah, so as you see there, it's the x-axis. If there's x-axis collision there, or this is before the collision as well, so then I still allow the z-axis movement, and it's the same for if it's z, allow the x. So that's similar to how it was, I think, how I was talking about it in the last video. But now with this being calculated here, it doesn't, you don't get stuck in the corners, you can't pass through it. And I've added this for above and below, because what it was doing, and I'll show that quickly, if I go to this tree here, when you were on top of it, you were stuck, you had to just jump off, so it wouldn't allow XZ axis movement at all. But now, yeah, you can move on the top of the models, not get stuck, and yeah. So that's when you're above or below it, then we're setting the Y velocity, so gravity affected, because without this, when you're standing on top of the model, gravity, so your Y velocity would keep going down because of gravity. So I'm just setting that to 0, and then I'm allowing X and Z movement, and exactly the same for AABB, so model collision box instead of the custom vertices for the OBB. So I'm just using the min and max for that model. So that's, I just want to go into this so I can explain a bit better why I was doing it this way, because I know there was a reason, but I just can't remember, and I don't like how I was explaining things previously in the other videos, especially like how I was explaining the OBB. So yeah, here, so say there's a collision, say there's a collision event, we're now updating position, we collide with the wall, we're changing the cam position and target to its previous position. So this applies to the cam, it doesn't apply to the player. So the player's bounding box, yeah, this is right, yeah. So this applies, but it's updating your cam position. It hasn't updated your player's bounding box just yet. So then your camera is updated, and then we go into handle vertical. This is the future BB actually, because it hasn't applied the bounding box yet. So if I go to player, so it runs that, player gets updated after. So previous position gets set as that cam position. So where's current position? So here, player bounds. So this is exactly the same as this collision here, future BB, except this gets calculated after all the collision has been handled. So I'll show you in the update. Find all references. So here the player gets updated. Oh, so I have it before. So player gets updated. The collision then happens. So here I've got, so player updates, that collision happens. I don't think I need that, hang on. So player is getting updated before. Well, I may as well try it. So let's see. Oh. Okay. Which one is it? Bounding box. Player to player bounds. So if this is exactly the same as I think, because it doesn't seem to be any difference with player update occurring before the collision. So maybe I said that because I wanted it to be future, but then I changed it and I haven't realized that it's exactly the same. So let's see. Yeah, I'll just switch it to screen to window capture so it's smoother. There we go. Doesn't seem to be getting stuck in the corner. Oh wait. Yeah, but I'm not sliding against it. So yeah, I think so. This actually is more like So this is the BB before it. So this is the frame before it's collided. Actually, no, this is the frame after it's collided. So the player BB. Yeah, this is. So this is what's happening. This player's bounding box is getting. So this is current. So say it's the current update frame. This bounding box has the collision. So this bounding box is currently inside of the model's bounding box, or OBB, the model's collision box, or OBB. But this one here, this one contains the updated bounding box. So this is the future BB. So I can't. This is what I mean when I say I don't pre-plan these videos and kind of go through it on the fly. Have these type of problems where I'm explaining something for 10 minutes because I've forgotten why I did it. But yeah, so this has the updated position. So the player current bounding box, it doesn't have this ResPos adjustment applied to it just yet. So the player bounding box is still inside of the model. This one has been pushed outside of the model, so that's why as well these are checks that it's outside, because max x being less than the min x of the model, that's saying if that's on the outside. So if it's on the outside, so if it's more to the left of the model, or it's more to the right of the model, then we allow that the z-axis movement still. So it's still allowed to move forward and back, and the same with that. So I hope that's a better explanation. I've painstakingly gone through that because I wanted to explain it properly. I didn't want to do what I did in the last video. Except I didn't switch back to desktop. Yeah, but hopefully having my voice there was enough. But yeah, as I was saying, this future BB is outside of the model, and the max X and min X there is outside of the bounds. So this is always going to be outside of the, so this will never collide with the object. This is always the after collision bounding box, and I'm doing it there because the player doesn't receive the update until the next frame. So that's that collision there. Alright, moving on to interaction. So at the moment I've just set up this class which has that static int. So you have to be within a certain range of the model to be able to interact with it, and that's this. And we're passing in collision here as well, and the player. We have sound effect. At the moment I've just got one sound effect. Door 1 is the one that doesn't move. This door 2 was that see-through one that moves. And then my model has a model state now, which only the doors are using at the moment, but other objects can use that as well. So that's why I've put it in the model itself. I was thinking to do a new door class and have that inherit from the model render, but yeah, I just didn't really want to do that. I'd just rather keep it in the model render for now. So yeah, so here in the interactable, as it's going through the collision, it's checking if it's interactable. If it is and you interact with it, then Then we check what door it is. If it's a door 1, we play that. If it's door 2, we play that. That can be a separate sound. And we then update the model state and its active rotation. And then after all that, we check if the model that we interacted with has a level location. So if it does, if it's not equal to none, then we transition the level to that. So here we have a start position being passed in, which we have the model's interactable set player position. So this is a vector 3, which is pretty straightforward. So here we have 3 things now for interaction. We have the model's interactable level location, which is the level that model is going to send you to when you interact with it. This player position it sends you to when you interact with it, and the type. So where I'm doing that is here when we're setting the interactable. So this is for ones that we're just using none. So in set interactable with this one, well, this is ones we don't want them to be a level transition or whatever. These ones when there is, so we're setting a level ID position to set, and then that gets set to where we're going and the type. So if we check this one, we can see, so here I'm saying, well, for now anyway, that last door 1, so this is level 2 but level 1, set interactable here. As you can see, so here I'm it's door 2, door 1 here. So I'm setting all of them, so here I'm not setting any, but set interactable just for one of those doors, and that's the first door. I'm setting it to go to level 2, and then interactable positions, set player at this. So this is a list of, so this class is just vectors. So here it's level 1 to level 2, that casts that vector. So that's the position of the level 2 door. So if I was to change, it's a bit cleaner, but if I was to change the position of that door that I wanted to transport you in front of, I would have to change it. So if I change it on the level objects here, I would have to change it in the interactable positions as well. I did want to have that linked, so if I changed it here, it would update both, but let's find where I'm. Oh yeah, so I am doing that. So here when I'm setting that door position, I'm using the level 2 door to level 1. So I'm using this to set its position, and I'm using it to, if I go to level objects, I'm using it here to set player when we transition. So that's interactable positions dot set player down here as well. I'm using that position X and Z because these are at different heights to the player, and then I'm just adding a position +3 on the Z axis, and that's where I'm setting a player when it transitions. So yeah, I am using these vectors in both. So I only need to change it. I only ever need to change it once in that interactable positions. So that's that's when I interact with the object. So that's the level transition as well. And then yeah, check interactable here. And yeah, that's pretty much the interaction class there. If I go back to level objects, let's see if yeah, it's not in level objects, it'll be in level itself. Level. So level, yeah, only doing query and check interactables for that. Check interactable, I'm only using to detect whether I should draw that string to screen or not. But yeah, that check interactable and query interactable work similar. Like query interactable is just wrapping check interactable plus doing all that added functionality as well. So that's interactables. Now split models and textures, I think I went through, yes. I'll go through the door. So let's say we interact with the door. Where do I have all that? So if I go back to interactable, here, yeah. So here, so the rotation that gets handled in the model itself, and what I'm doing when we interact with it is we're changing its state, and then we're setting an active rotation. So let's say the state was closed when we interacted with it. We change the state to open, and we're rotating it on its y-axis, moving it 3 units per frame, and then the opposite, if it was open, we're closing it. So why I have these open and closed, because if I didn't, this would just continuously rotate, but I want it to rotate to a specific point, and at the moment I only have it when the model is, so the model starting rotation is 0, but that's easily the functionality is easily changed so that it can handle all starting rotations. But yeah, so here I'm saying if there's an active rotation along any of the axes, then if it's a door and it's open, and so this is what I mean by it's only doing it at the moment if its starting state is rotation 0. So here I'm saying from 0 to 90 degrees we apply the rotate with position. So if the state is open, so you know we're closed, the door is closed, it has rotation 0. We click it open, the active rotation starts incrementing its rotation from 0 to 90 degrees, and it hits, or under 90, it hits that, and then it doesn't apply anymore. So that's when you open it, gets to a certain point. This can be easily added start state. So if we have start rotation, all we need to do is and I have this separate to rotation because I was just looking at this and remembering why am I doing that again. So we have this separate because rotation is the current rotation, start rotation. So if we do start rotation, set it to rotation here as well, this will never change, even though rotation will. Do it on this one as well. Where's rotation? Here. And then what we can do on this is start rotation plus start rotation plus that. And then here, start rotation plus rotation Y. There might be something I'm missing, but yeah, it's still working. So this, because it has a rotation 0, it's no problem. But now, if we have a start rotation of 90, then it'll say from 90 to 180 degrees. Then we apply this rotate, and then here, if it's, let's say we start at 90, it'll be 90 plus. Do we need this to be start rotation Y or 0? I think, yeah, this needs to be like this as well. Yeah. So yeah, then here we have the start rotation plus the rotation. If that's greater than the start rotation, then we close it again. I'll just double check that didn't break the close. I mean, I shouldn't for this anyway, because this has a 0. Start rotation Y is 0 anyway. I'll have to test that. But yeah, and then if either of those things, then we can check as well. If the model type is not a door, then this is rotate, just the standard rotate. So rotate with position compared to rotate with position is the non-centered position. So this gets used for the doors because we don't want the door to rotate along its center. We want it to rotate along a specific axis. So for here, a hinge on the edge. To rotate with position, pass in that rotation, and if it's constant or not. So if it's not constant, or it's going to be a ramp. So we can, if it's say one of those floor tiles, and we rotate it along a non-centered, we can have a rotation as whatever we want, and then it's still a ramp. And then we do so this is what I was talking about with the rotation calculation based on a separate position. So here what I'm saying is, so that door, instead of rotating it on the center, we're moving it negative width, so half of the negative width, which is the edge of the model on the x-axis. So that, looking from, as we saw it before, that was the rightmost, but I'll just go into it and show. And look at it from this direction, because this is from 0 rotation. So this is the usual point that it rotates, right in the middle. What I'm saying is get this point here, which is minus the width, minus half the width, which is that point. And we're saying rotate. I'm doing a calculation of that point rotation. So that's this, half the width. And then I'm saying I'm only getting X and Z axis rotation at the moment. But yeah, if we wanted to rotate on a different axis, we just do the same like this. But yeah, for this is X and Z. So we're saying, and this is the same formula I used, as I said, in laws of Delusia for the bullet start position calculation. We're just getting the negative rotation, so X cosine the negative rotation minus Z sine the negative rotation for the X, and then for the Z, which gets cast to the right pos x, z, y, we're saying x sine rotation, negative rotation, plus z cosine negative rotation, and then position is equal to position no rotation minus that rotation calculation there. So as you see, and then we're plussing with, this was important because that was part of the movement. So if I remove that, the door would move away or slowly. I'll show you actually. So if we don't have that, that's that snap at the start actually, it's not the slide. So if I didn't have that, if you watch closely, the door moved a little bit, and then it actually does everything from this point, and we don't want that start snap, so we just add the width back, and then we update all the position for collision box, frustum view sphere, interact sphere, and the OBB. So we update all that so that the collision and interaction works with the updated model, and that's all that. That's the doors. I think that's everything about the doors. What else? All in door collision. I went through all the collision. I went through that rotation. I went through save and load, I think. I briefly went through. There's not much to go through with that. But yeah, save manager. And now I have to change that. But yeah, when you're hashing. So here I'm just using MD5. I've got my passphrase and salt, so these get put in the encryption. This is all. So this is all part of system security cryptography inbuilt into C#, and then so this just hashes the string. So here you can see I'm casting the string to a file. This one doesn't get hashed. This does when I run encryption, and then it's the same with the decryption. We just do the opposite. So where am I doing it? Yeah. So when we save, we encrypt this string, which then grabs this string and runs it through its hash. And then we pass in the salt and the passphrase, and then we encrypt, and then the opposite for the decrypt. So create decryptor here, create encryptor there of that we're cast into byte array, So I have to change that now because we don't want you to know the salt, so you can decrypt the save files and give yourself whatever items you want. But that's pretty much the save. Lots of balls there. So I'm doing it like this with these balls because let's say I add a new thing I want to save to the ini or to the game data save, then I can just simply add it like this, and I don't have to rewrite the entire. It won't corrupt old saves. It'll just say, all right, old saves got all this. Old saves got inventory, but it didn't have the interact. So then I can just, so if it didn't have it, well, not here, but let's say it was, this actually is if it's corrupted, but down here, yeah, so if it didn't have interact, then I just add it there and then I save. So on load, I'm actually loading and then resaving, and that's so it's update friendly, and I can add more things to that file if I need to, and then if the file doesn't exist here, yeah, we don't have to break old save files. So like this, for example, the save currently has just these. Next time I add stuff, I will I can just add a new row here which checks for the file, and then so this is load, and then if it does, so let's say I have a new, so let's say I add a new thing like money, right? It's player coins. Then I say else if player coins. So this, on the first run, it won't exist on the save, so this won't set the player coins variable, right? And then, oh, I'm not doing it. Oh, it'll happen on save, not load. Yeah. Although I actually haven't, I don't think I've implemented it on save info data yet. But yeah, it will work the same as in the ini. It would, so like this. Am I not? Yeah, I'm not doing it at all for the game data save at the moment. But yeah, it would work the same as this. Here I'm checking, so say I added a new one like interact, if this didn't exist. So if this was just added, the save file wouldn't have the interact string or whatever in it. So then this wouldn't run, and then b loaded interact wouldn't be true. So then we'd go down here, b loaded interact. We set it to our first one, and we save the new file with that default value. And then from then on, it would have interact as E, and then if you change it to say F, then interact would be like interact, key interact, F, and then we can load from that. So that's how I'm handling if there's updates. So as you see here, I'm not doing it on the game info data yet. So that needs to be added. So I just have to, I'll probably do that after I finish recording, because I thought I had set up all the core stuff for the save file. But that's save. And then I'm pretty sure that's everything in game. I'll just quickly show the instancing. So this was, yeah, this is a copy of, I forget who, here we go. Yeah, this was where I grabbed it from, the GitHub of this person, and they gave a example of hardware instancing with base vertex, so the primitives, that is the binding with primitives. So yeah, here is passing position and texture coordinate texture. I really want to see how texture was being, so yeah, he's doing a separate, which is what I'm doing now, separate for the models. And then how is he passing it to the shaders? This effect parameters, cube texture, set value, texture. So maybe I can get it to work like that. I think I tried it with in in this, but I'll probably try that later on as well in game, is have a texture parameter. Now his shader was this one, I believe, cube texture, and then so this is the shader for, so this was the original shader. So he has a texture and a texture sampler, passes in that, gets texture coordinate 0. I think with texture coordinate 0, I was having a bit of trouble. Let's see. So I've got this same thing, passing out to texture. I'll have to go through what I'm doing wrong here, but yeah. And then, so this is the shader he's written. So we have the output, he passes in the input. This is the position, and he passes in a coordinate. So this coordinate here gets changed based on the, if I go back to cube map, cube map. Where is it? So he has a struct. Where is he struct? Grid. He has a coordinate. Game 1. Let's see. Well, this is how I'm using it at the moment. My new Draw 3D, which was reverse engineered his stuff. So I've got 555. So that was actually 555 times 555 instances. So that's a lot of instances, and it was still getting some good FPS. So here, X and Z, and then instance count is just that, and then I'm creating a new instances array of cube info at that size, and then I'm setting world and the coordinate, so atlas coordinate for all of them is 1 1, and world is getting set to I multiplied by 8, 0, j multiplied by 8. So this is just a 2D, a for loop. So it's like a 2D, that's how to do a 2D grid there. And then I thought I was setting atlas coordinates, but looks like I'm using just world. Then I'm passing in only world view projection. So instances are getting put on the instance vertex buffer based on dynamic vertex. I'm using a dynamic vertex buffer there. Alright, so here I'm setting into for instance count, and then I'm setting data on each for those instance, for that instance array. So instance set data instances, and then so on that instance vertex buffer we have that array, that 2D array. Well, not a 2D array, it's just a single dimension array, and then we're creating a new vertex buffer combining the instance vertex with the the vertex buffer of that model. So this is the vertex buffer. This is just one this is just one model, right? And we're combining that with the vertex buffer, the instance vertex buffer array, so that it draws this many times on that coordinate, and then graphics device indices at the index buffer there, and then we're passing in the world view projection, which is its position in the world based on your camera look. And then if we wanted to pass in textures, we'd do what here would, and then pass in the textures there. And then I think it might be because draw index primitives, I don't think that's why. But then we're drawing for that mesh. So that's pretty much where I was at with instancing. But again, I spent a lot of time trying to understand instancing and the shaders and getting a decent understanding, but there's still a lot I think I need to learn with shaders, especially because as you saw, I can't get the texture info in on the even on the default shader, so I might play around with that even with the new model and texture split that I've got in the game. So I think that was everything. This video has gone for ages, but yeah, mainly because I don't pre-plan this, I think, and my explanations are probably not the best, but that's everything. So thanks for watching. I was pretty excited for the new models and the new collision. Yeah guys, thanks for watching. I'll stop this here.